Hello everyone. In this video, we will discuss about the solution for the question number 49 that was asked in D2023. So the question is to find out the period of this discrete signal x of a, which is the combination of these three signals. The signals are there is a DC signal and there is two sinusoidal signals. So we have to find the period of the signal, and this question is from the topic of discrete digital signal processing. So the basic concept is if you have two periodic signals of fundamental periods n1 and n2, then the sum of these signals will be periodic if there exist positive integers a and b such that n1 is equal to n2. So suppose if you have a signal that is a composition of two signals, and if you know the period of first signal and the second signal, then the condition that x of n will be periodic is that there must exist integers a and b such that n1 times a1 times the period of the first signal equal to b times the period of second signal. So this a and b, the condition is that it should be an integer, and as keep in mind that as this is a discrete signal, n1 and n2 also will be integer. So the basic concept is that there should exist two integers a and b such that a into n1 equal to b into n2. That is the condition that x of n will be periodic. So in other words, we can say that a times the period of the first signal will exactly line up with b times the period of second signal. That is the interpretation of this. So that means a times the period of first signal after a times the periods, the first signal will exactly will line up with b times the after b times the period of the second signal. So this equation can be interpreted in that way also, and the period of this composite signal will be the LCM of n1 and n2, and that we can consider that as the fundamental period of the composite signal. Here, if you are doing the problem, you can see that there can be many a and b values that satisfy the equation. So in order to find the fundamental period, we don't have to take all those a and b values. We will take the value of a and b where we can have the LCM of n1 and n2. So from many values of a and b, we will take only the particular value where we can get the LCM of n1 and n2. So we can consider the fundamental period of the composite signal as the LCM of, that is least common multiplier of n1 and n2, where n1 and n2 are the period of the first and second signal respectively. So if you want to check whether this is a this composite signal is a periodic signal, we can check the ratio of the signals present in the composite signal. That means if the period of this signal is n1 and period of this signal is n2, and we can check n1 by n2 whether it is a rational number. If it is a rational number, then the composite signal is a periodic signal. Otherwise, it will not be a periodic signal. Why this is rational? Because n1 and n2 are integers. Because n1, what is n1? N1 is actually the period of the fundamental period of the a discrete signal, right? N1 and n2 are period of discrete signals, and period of a discrete signal must be an integer. So we will have integer divided by integer. That means that's a rational number. When it is a rational number, then we can say that this is also a periodic signal. So in that way, we can check whether the composite signal is a periodic signal or not. So with this concept in mind, we will go to solution. So here we have three signals: signal 1, signal 2, signal 3. Signal 1 is a DC signal, signal 2 and signal 3 are AC sinusoidal signals. So when you are considering the signal 1, that is the DC signal, its period will be 1. So period of a DC signal is 1, and it will actually, the DC signal will not affect the period of the composite signal, total signal. So we don't have give much attention here, because this will not affect the period of this signal, because its period is 1. Period of the DC signal is in discrete system, it is 1 only. Now when we are considering the other two signals, let's calculate the periods of the uh, signal 2 and signal 3. So coming to signal 2, we can have 2 pi f1. This is actually omega, 2 pi f1, omega equal to 2 pi f. So with that concept, omega 1 equal to 2 pi f1 equal to 15 pi by 8. This is the value with the n value, right? In case of a continuous signal, this will be t. In case of a discrete signal, this is n. So we will check this omega value, that is 2 pi f1 equal to 15 pi by 8. From where we can get f1 equal to 15 by 60, and that is equal to k by n1. Because frequency, we know it is the reciprocal of the time period, right? So similarly, in case of a discrete signal, it is n1. In case of a continuous, in case of a discrete signal, the time period we represent as n. But in case of a continuous signal, it will be t. So we have f1 equal to 15 by 16, that is equal to k by n1. This n1, 1 by n1 is coming because frequency is the reciprocal of the fundamental period, right? So that concept is, but that is why this is coming 15 by 16 equal to k by n1. So we can take any value of k. I will come to that point. So before that, we have n1 equal to 16 by 15. From there we will get n1 equal to 16 by 15 into k. We can take any value of k such that or in another way we can think like this. N1 is the period of the discrete signal, right? So as I mentioned here, period of a discrete signal must be an integer. So in order to make this as an integer, what we can do, we can take k equal to 15. So in that case, we can have n1 equal to 60. So we can have n1 equal to 60. In the similar way, we are analyzing the second signal. So again, here we can see omega equal to pi by 3. So 2 pi f2 equal to pi by 3. Then f2 equal to 1 by 6 equal to k2 by n2. n2 is the period of the fundamental period of the second signal. So n2 equal to k2 into 6. So as I said earlier, this should be an integer value. In order to make this as an integer, what should be the value of k2? We can take it as 1. So n2 equal to 6. So now we will check whether this signal, the total signal, is a periodic signal. So that we can check like n1 by n2 equal to 6 by 16. So it's a rational number. So that means the total signal, the whole signal is a periodic signal. This whole signal is a periodic signal. Now what you have to find? You have to find the period of the signal, right? So the period of the signal is nothing but the least common multiplier of n1 and n2. What is n1 and n2? The time periods of the signal. So the least common multiplier of n1, that is 16, and n2, that is 6. So its least common multiplier is 48. So the answer for the question that we are discussing here is 48, because it is the least common multiplier of 6 and 16, where 6 is the period of the second signal and 16 is the period of the first signal. So the thing is that if n1 by n2 is an irrational number, then the signal is aperiodic. Suppose instead of 16, we got n2 as pi. So 6 by pi, 6 by pi is not a rational number. In that case, the signal will be aperiodic. So there will not be, can say anything about period because it's an aperiodic system. So if this condition is satisfied, that means n1 by n2 is rational number, then we can go for the we can calculate the LCM of the two signals. Not two signal, whatever the signal present, it's the LCM of its time period. That will give the fundamental time period of the composite signal. So the basic concept is we will calculate the period of the first signal, period of the second signal, and period of the whatever the signal is present. We will calculate its fundamental periods, and we will calculate the LCM of these fundamental periods. It's actually very simple. The first step is calculate the signal time period of the first signal, calculate the time period of the second signal, calculate the time period of the third signal. Then we will calculate the LCM of all the signals. In order to calculate the uh, uh, fundamental period, we will equate this omega to 2 pi f1, where f is equal to k by n. So from there we can get n. So n should be an integer. So we can take here in this case, if the value of k equal to 15, then n1 will be 16. Similarly, we will solve for the second signal and we'll find the time period of the second signal, and from there uh, we will find the LCM of the two time periods, which is equal to the time period of the total signal. So this is the concept, and this is actually very simple. So if you want to know more about more theoretical background, you can refer to this lecture. So that's all about the video solution. Thank you very much.